Everyone can hear me? Online students, is my voice is loud and clear? Online students, is my voice is loud? Right, done. So let's start this. So in the last class, we have discussed about the ridge regression, right? And how to work on the ridge regression and what are the different hyperparameters or what are the different So in the last class, we have discussed about the ridge regression, where I have selected the data set called as insurance data set. And for this insurance data set, we have done initially the exploratory data analysis, followed by data processing, that is data cleaning and data wrangling, and then followed by train test split. And once it is done, then we have done the modeling and evaluation. And once the modeling and evaluation is completed, then we have done the hyperparameter tuning, that is different alpha values. We have tried with the different alpha values. And once we tried with the different alpha values, we have got the best alpha value as 0.9. And using that best alpha of 0.9, we have rebuilt the model. Once again, we have rebuilt the model. And finally, we got with respect to the train accuracy and test accuracy with the CV. And if you want to predict on any new data, then that new data has to be pre-processed in the same way. Whatever the above, we have done that same pre-processing. Here also we have to do the same kind of data pre-processing. Okay. And then we have to give this pre-processed data, that is transform data to the model, and the model is going to predict the answer, right? So once again, in the last class, whatever I have discussed, I'm writing here the step by step. First, I have understand the business problem of the business problem is where I have to predict the expenses with maximum accuracy. This is my business problem. And next, I have collected the data and I have understand each and every column where I have understand the data very clearly, data understanding. Once the data understanding is done, for later I have done the EDA. Okay, just observe this one. I have done the EDA. After understanding the data, I have done the EDA. After doing the EDA, next I have done with respect to called as data cleaning. Now next time I have applied data cleaning. From the data cleaning, next I have moved on to the data wrangling, that is encoding. For this particular data set, I have done the data wrangling of encoding. After data encoding, I have selected my X and Y, whatever the X variable and Y variable I have separated. After that, I have done the train test split. After that, I have done the train test split. Once up to this is completed, now I'm starting the modeling. In the modeling, what is the first step I have done? What is the first step I have done is, that is in the modeling, what is the first step of modeling is, first I'm trying with the default parameters. First I'm applying the model with the default parameters and I'm going to evaluate with the default parameters. I'm doing the evaluation on the default parameters. Next, so it is better to write in the notes clearly, step by step, because the same thing we are going to apply in the today's session and even in the Kaggle competition also. Okay, same to same step by step we have to do in the Kaggle also, not only in Kaggle, in the company also. For the regression algorithms, the same process. Okay, first step, step by step process, heading as step by step process for regression projects, for any regression based projects. Okay, first one is business problem understanding. Business problem understanding. Second one, data understanding. You have to understand the data very clearly. Data understanding means understand each and every variable clearly. Once this is done, step number 3. Step number 3, do the exploratory data analysis. Exploratory data analysis. Once exploratory data analysis is done, then you apply the data cleaning. In the exploratory data analysis, what you are going to analyze means you are going to check whether there are missing values are there, or which type of data is which one, how many nominal data are there, how many ordinal data are there. Everything you are going to check here. Checklist. You are going to make the check. All the variables you are going to check individually, and everything you are going to understand the each and every variable clearly. Exploratory data analysis means understanding each and every variable. For example, it is a categorical variable means how many categories are there. If it is a categorical variable means how many categories are there. At the same time, whether it is a nominal data or ordinal data, whatever you have checked, everything you have to write the notes. Whatever you have checked, you have to write the notes. Okay. If it is a continuous variable, whether it is a skewed data or a normal data. If it is a continuous variable means skewed data or normal data, or whether it is having outliers, or whether it is having missing values, all these things you are going to check. You are not going to treat anything, just you are going to check only. Okay, this is the column. In this column, some missing values are there. And this is also having some outliers. And this is having some skewed data. And the magnitude is very high. Whatever you have observed for that particular column, just you can write everything. Whichever required for data cleaning and data wrangling, that observations you are going to do in the exploratory data analysis. Now, general data analysis is different. That is a data analyst, what he is going to apply, that is entirely different. Here, the data for whatever the data cleaning or data wrangling we have to do, for that we are going to check. Now, after doing this data cleaning, we are going to do the data wrangling. Once the data wrangling is completed, next we are going to select which are X variables and which are Y. X and Y we are going to separate. Then we are moving to the next train test split. Train test split. We are going to split the data to train test split. Within the train test split, we have to identify the best random state, and we are going to fix that random state. Okay. Now, with this, the initial step was completed. Now, next, we are going to try with different algorithms, one after one. First, we'll start with in the modeling. First, we'll start with always linear regression. So we'll start with linear regression. So in the modeling, first we are going to do the default parameters. For any algorithm, first we are going to apply the default parameters. For the default parameters, we are going to do the evaluation. What would be the evaluation? First, we are going to apply default parameters. After applying the default parameters, we are going to evaluate the model. And we are going to note the test accuracy, train accuracy, and CV. And we are going to decide whether our model is a good or a bad one. Okay. We are going to do the modeling, evaluation, and model selection at a time. Modeling, evaluation, and model selection. 3 of them we have to apply at a time. How we have to apply these 3 at a time? I will show you once again. So default, first you are going to try with a default parameter. After that, you are going to calculate the train and test and CV scores. And based on that, you are going to say whether it is a good model or a bad model, right? Now, then what you are going to do? You are going to apply a hyperparameter tuning. Hyperparameter tuning. And from that hyperparameter tuning, identify the best value. for the hyperparameters. For hyperparameter, identify the best value. Once it is done, rebuild the model. Rebuild the model with best hyperparameters. Rebuild the model with best hyperparameters and calculate the test, train, and CV scores and decide whether it is a good or bad. Right? So this we are going to do for each and every model. Now just done. Please write everything. Done. The same thing, whatever I have written in the board as of now, the same thing I have.
Recording stopped. Recording in progress.
Yeah. So guys, online students, can you please once again confirm? Is my voice is clear? Done. Okay, fine. So whatever I have written here, right? The same thing. Whatever I have written here, the same thing I have written in the Word document. Just I'm showing you here. Okay. Just a minute. So just observe in your notes and this one same or not. So here we are having the CRISP-DM methodology. First one is business problem understanding. Understand the exact business problem, whatever the requirements of the client is there, understand. Next, data understanding. What is meant by data understanding? Means extract the data from the database. You have to take the data. In my case, here in these examples, I'm giving you directly the data set, that is Excel sheet or CSV files. Once I explain the SQL, there I'll show you how to extract the data from the database, right? You are going to extract the data from the database and you are going to understand each and every variable clearly. If required, you are going to take the help of the domain consultant. There will be some domain consultant and you are going to take the help of him. Okay, if it is a unknown data, means you are completely working on a particular domain where you are not even having a zero, even 1% idea. In that case, they are going to allot the domain consultant. For example, in your team, none of them knows about that previous domain. None of them has worked. For example, in my team, related to aviation, we are going to work on the aviation project. None of them has worked earlier on the aviation project, and none of them belongs to related to aviation. In my particular team, there is not even one member background is aviation, or they're having some idea about the aviation also. None of them is there. So in that case, what we are going to do, since we don't know anything about that, and if you do the research in the Google, high technical words will be there that we can't understand by simple things, because aviation degree is there, means in the degree, whatever we are having in the final year, that we can't understand. First year degree or second year, basic terms only we can understand, but high level technical terms we can't understand. In that case, what we are going to do is we are going to hire one person called as domain consultant in a company. The team leader, the project manager is going to hire one person called as domain consultant. He will support for that. And here we are going to understand each and every variable very clearly, and we'll understand the data set. In our data set, how many records are there, how many columns are there. Within that, we are going to list the complete discrete variables and continuous variables we are going to separate. And for that, we are going to do the EDA. That is, in the given data, we are going to apply the univariate analysis, bivariate analysis, multivariate analysis, and also we are going to check how many columns are having the missing values, how many of them are having outliers, how many of them are skewed, how many of them are discrete nominal, and how many of them are discrete ordinal. We are going to take a list of them separate. So wherever the missing values, whichever the columns are having missing values, those columns we are going to treat in the data cleaning. Whichever the columns are having outliers, those columns we are going to treat in the data cleaning. Whichever the columns are having with respect to discrete nominal, we are going to do the encoding accordingly. Whichever the columns are discrete ordinal, we are going to do the encoding accordingly. So we have to do the data cleaning or data wrangling on the particular futures. Means first we have to understand which future is having that problem. Which future is having the missing values, which future is having the outliers, which futures are having the discrete categorical data. First, we have to list them. So this is called as list. We are going to check and we are going to separate them, and we are going to write in the notes, okay, these columns are having this one, this one, this one, like this. And once we understand the data, then we are going to do the data pre-processing accordingly. In the data pre-processing, we are going to drop the unimportant variables. By seeing itself, we know serial number will be there. Serial number is not important. Like name of a particular person will be there. Every person name will be different. For example, I'm working on a hospital data. In that patient, every patient name will be different. What I will analyze on the patient name? Patient name, there will be no use. Instead of patient, what is the problem he is having, we are going to analyze. That is okay. Patient name, what it says us? His age, okay. What is the phone number? What is the what analysis we are going to apply on the phone number? No analysis we are going to apply on the phone number. If whatever the mail ID he has provided, there is no analysis on the mail ID. So just that we are going to ignore those columns. Simply we can delete. Okay. So directly, which are unimportant variables, for that no need of statistics or nothing. Just minimum common sense is sufficient. Okay. Name is not sufficient, not required for this particular things. For this particular project, a name or not required, or phone number or mail ID is not required. Based on the common sense, we can delete. For that, no need of statistics or no need of anything. Just only basic common sense is required for that, right? Based on that, we are going to drop some of the futures at the starting only. By seeing itself, we will drop. This is unimportant. We'll decide by seeing itself. Someone says that, sir, what would be the data scientist salary? Means if my father name is this, your father name is useful for this analysis, sir. For predicting data science salary, father name is useful. That is basic common sense, right? Simply we are going to delete. For COVID case, whether to predict whether the person is having a COVID or not, for predicting that COVID or COVID cases or something related to that, is the mobile number is important, or number of times he has tested the COVID, that or what is the test center he has spent for the COVID test. Test center is important. If he goes to Malaysia, Delhi means he will get the COVID, and he goes to Bangalore means he'll not get COVID. Nothing like that, right? So simply we are going to test center is not important. In which case it is not important, in which case it is important. For example, same test centers for Naresh IT in Delhi is there, Chennai is there, Hyderabad is there. Then how many students are enrolling in Delhi, how many students are enrolling in Hyderabad, and how many students are enrolling in Chennai is important. That is important. In that scenario, it is important because we are predicting the number of students at the each center. First, we have to understand the business problem. That is the reason we have to understand the business problem. Based on the business problem, we can decide everything. If the business problem only not clear, we can't decide anything. For which business problem, which variable is important, which situation is important, which column, which future is important, and how we have to process means, first we have to understand very detailedly the business problem. What exactly on what parameters we are working and for what purpose we are working, and finally what we want to conclude from this and what we have to do. All these things we have to understand in the business problem, right? And the future selection followed by data cleaning, followed by data wrangling, followed by train test split, and you are going to take the evaluation. You are going to do the evaluation where you are going to import the algorithm with default parameters. First, you are going to do the default parameters. You are going to fit on X train, Y train, and you are going to predict on train data, and you are going to predict on test data, and you are going to evaluate the train accuracy, test accuracy, CV, and from that you are going to identify whether your model is a good model or a bad model. And coming to the next, you are going to apply the hyperparameter tuning for each algorithm separately, because for each algorithm, the hyperparameters will be different. For polynomial regression, the degree is there. The same degree is not applicable for the lasso regression or ridge regression. For polynomial regression, degree is important. For lasso regression, alpha is important. For ridge regression, alpha is important. For elastic net regression, alpha and lambda also important. Lambda means L1 ratio, how much percent of lasso and how much percentage of ridge we have to consider. So for each algorithm, different parameters will be there. So for we are going to apply the hyperparameter tuning for each algorithm separately, and we are going to identify the best parameters. And once we identify the best parameters, we are going to rebuild the same algorithm, this time by considering the best hyperparameters. Again, we are going to calculate the train accuracy, test accuracy, and CV. And we are going to store this one, and we are going to decide default is best or this one is best. If both of them are same, then automatically by default is the best one, because it will take less time. Okay. Next, model selection. We are going to do the model selection. Once each and every algorithm is completed, finally we are going to decide which algorithm is well suited along with the hyperparameters for the given data set, which is the best suited. And that best suited algorithm we are going to save, and we are going to predict on the future data. Now the same thing, this is called as complete capstone project of data science. Now the same in the last class, I'm not saying today's class, in the last class, whatever we have done, just I'm showing. First, we have done the business problem. I'm keeping both of them side by side. First, we have understand the business problem. Here I have told you, we have to predict the expenses with maximum accuracy. Whatever we can do with maximum accuracy, we have to spend the expenses. Now, this is the data set where I have explained each and every variable. Understand each and every variable. Okay. So understand each and every variable very clearly. That is age column followed by gender. What is meant by BMI? Children. Children is a discrete count variable. So it is comes under discrete. And we have to check whether the person is having how many number of children, and smoker, whether this person is having a smoking habit or not, and what is the region he belongs to. I have explained you each and every variable clearly, right? And from that, we have understand the data set. That is, it is going to consist of 1338 records and 7 columns. So these are the 7 columns. Next, list the discrete variables and continuous variables. So we have separated, these are the continuous variables and discrete variables. After separating the discrete and continuous variable, next we have to do the basic EDA using the pandas, matplotlib and Seaborn. Since for discrete variables, I'm going to do with respect to value counts, means each categories, how many categories are there. This I can do here in this way, or I can even apply this one called as df.describe function. I'm going to use the describe, inside which I'm going to write include is equal to object. I'm going to take directly object data type, whichever is in the object format. Df, whether df is there. Include is equal to object, or directly we can take here instead of this we can write here itself the discrete dot describe. So it is going to take all the discrete variables. What is this? Region. Okay. Again, let us So now it is applying where I'm having the discrete variable. So the list of discrete variables, what is the list of discrete variables? That is sex, smoker, region, and children. Just give me a minute, guys. Include all is there, right? So all columns. Okay, so include is equal to all, or you can write with respect to include is equal to object. So if you write include is equal to all like this, so here directly you can get with respect to for discrete variables, for each discrete variable total how many unique categories are there. That is gender is having, the sex is having 2 unique categories, smoker is having 2 unique categories, and region is having 4 unique categories. Now now it is clear what is the problem is. Here the children is in the numerical format, remaining 3 of them in the categorical format. Since the remaining 3 of them are in the categorical format, one is in the numerical format, that is the reason it is throwing that error. Earlier example. Otherwise, if you take like this now, in this case, for example, if I take only these 3 columns, automatically it will give that one. Right? Since 3 of them is whatever the discrete variables are there, discrete categorical variables, for each category, you can get the unique values. At the same time, So the gender is having with respect to 2 unique categories, smoker is having 2 unique categories, and region is having 4 unique categories. So here directly you can take the discrete variables and you can apply the describe function over that, right? And you can see for the same answer you can see here by using the value counts also. Value counts also will give the same answer. For male in the variable you are having like gender column is having 2 variables, like 2 categories, that is male and female, and smoker is having 2 categories, yes and no, and region is having 4 categories, same to same, the unique values. And which is the top one? Mode is male because the male was repeated more number of times, 676. And in this case, smoker is the no smoker is the top one, that is mode. And in this, the most repeated one is southeast. So it is showing the southeast. The top is nothing but mode. It is just applying the mode, right? So just we are applying the describe function, and we are doing the basic EDA. And then what is the next step we are doing is we are identifying how many variables are having missing values or outliers, or which are now nominal data or which are ordinal data. And according to that, we are going to apply the data cleaning and data wrangling. So first I'm identifying how many of them are having missing values. And since there are no missing values, I'm not going to do any kind of data cleaning, and directly I'm going to do the encoding. Once encoding is completed, I'm going to select the X and Y. So in this way, we are going to do the X and Y. We are going to select the X and Y and train test split. In the notes, just open your notes earlier, whatever you have written. First, business problem understanding, followed by data understanding, followed by EDA, followed by data cleaning, followed by data wrangling, followed by X and Y. We have selected the same X and Y, followed by what is the next one? Train test split. So the same train test split. Up to here, it is common. Next, coming to the next part, that is modeling. Now in the modeling, what I have told you first, we have to do the default parameters. First, I'm going to apply the default parameters. For this model, I'm not giving inside anything. And if I don't give anything, then it is called as default model. Whatever the default parameters it is having, whatever the values it is having, it will take automatically. So this is called as default model. So this default model, I'm going to do the modeling with default parameters. And from that, I'm going to calculate the train accuracy, test accuracy, and cross validation score. Once I calculated these 3 of them, next, what I'm going to do, what is the next one? Apply the hyperparameter tuning. You are going to do the hyperparameter tuning, and you are going to identify which is the best values. So for this particular ridge regression, what are the hyperparameters we have to consider? Means alpha. Alpha is the hyperparameter which we have to consider. Now, what are the list of alpha values I want to try? Means 0, 0.1, 0.2, 0.2, and 0.3, and 0.4, 0.9, 1, 1.2, and 1.4. For example, I'm writing myself the values. You can write the values like this, or you can take a while loop and you can append everything, and this list you can pass here, right? So I'm applying the hyperparameter tuning, and after applying the hyperparameter tuning, I'm identifying which is the best alpha value. Now I'm going to rebuild. In the notes, what is the steps we have written? Modeling with default parameters. So modeling with default parameters. So I have done the default parameters, train, test, train, CV, and I'm going to identify whether it is a good model or a bad model. Completed. Next, hyperparameter tuning. Hyperparameter tuning means identify the best value for your hyperparameter. For every algorithm, the hyperparameters will be different. For ridge algorithm, the hyperparameter is alpha, and from the given data, it is identifying which is the best. And once identified the best, what we have to do? Rebuild the model with best hyperparameters. So I'm going to rebuild the model with best hyperparameters. Again, I'm going to calculate the train R square, test R square, and CV. Is that clear? So the same thing, whichever I have written in the notes also same. First, you are going to import the algorithm. You are going to fit on X train, Y train, and you are going to see. This is the default model. In the default model, first you have imported. and you have fitted on X train, Y train, imported, fitted on X train, Y train, predict on train data, predict on text data. And from that, you are going to calculate the train accuracy, test accuracy, and cross validation score. Once you have calculated, you are going to check whether your model is a overfitted model or underfitted model. At the same time, test accuracy is equal to your cross validation score or not. You are going to check that one. Once this is completed, next, what is there? Apply the hyperparameter tuning. So you are going to apply the hyperparameter tuning for each algorithm separately. For example, you are applying ridge regression, lasso regression, elastic net regression. Everything you are applying for on the same data set. Separately, you have to calculate. So you are calculating the apply the hyperparameter tuning. Apply the hyperparameter tuning is nothing but grid search CV. For each algorithm is estimator. Estimator is nothing but ridge. And identify the best parameters. Identifying the best parameters. Once we identify the best parameters, what we have to do? Rebuild the model. You are going to rebuild the model. Rebuild the model by considering the best hyperparameter. In the above grid search CV, what is the best parameter I have got? Alpha is equal to 0.9. So I'm going to rebuild the same algorithm. Rebuild the same algorithm. That is ridge regression. Once again, you have to rebuild by considering the best hyperparameter. That is alpha is equal to 0.9. And you have to substitute here. Earlier, you have not given that one. In the previous one, if you observe the previous one, you have just given only the brackets. You have not written anything inside that. Now, this time you have to write the alpha is equal to 0.9 clearly, because this is the answer which you have got in the grid search CV. So that answer you have to substitute here. And again, what you have to do? Evaluate the train test and cross validation score. Again, I'm going to evaluate the train test and cross validation score. Once it is evaluated, again, you have to check whether it is a good model or a bad model. Like this, you have to apply for each and every algorithm. Now, in the last class, we have done this one, right? Now, in the today's class, just observe. This is the ridge regression. I'm going to take the ridge regression side. And at the same time, I'm going to take the lasso regression this side. This is ridge. Heading is ridge regression. This is lasso regression. Now, whether it is a ridge regression, whether it is a lasso regression, up to data pre-processing, there is no difference. Only the difference starts from the modeling stage. Remaining up to that, up to train test split, there should not be any difference. The data should be as it is. Then only we can apply the different algorithms. So just observe this one. So here, whatever I have done, the same to same here I'm doing. And here I'm going to load the data set called as insurance data set, same to same. And followed by data shape and info, the same. And next, here I'm going to separate the data, that is whichever the data is continuous variable, categorical variable like this, I'm separating the data. And after separating the data, I'm going to do the value counts, same value counts. And after that, describe function. And after that, I'm going to take the correlation matrix. Once the correlation matrix is done, next we are going to do the data pre-processing. And here I'm dropping the region column, and here also I'm dropping the region column. Here I'm dropping the duplicates. Here also I'm dropping the duplicates. After dropping the duplicates, here the data shape is 1337,6, because one column you have dropped, that is region column, and one row you have dropped, which is the duplicated record, same to same. Next, here you are going to do the encoding, same to same encoding. Next, you are going to take X and Y, same X and Y. Next, you are going to take train test split, where the train test split of test size of 0.2, random state of 9. Here also the test size of 0.2, random state of 9, the same to same. Now, if you see here the X train data, first record is 390, followed by 1043, followed by 68. Just if you observe here, the data should be the same. Both of the data should be the same. Whatever the data you are having here, the data should be the same. Otherwise, we can't apply. So here, just I'm restarting the kernel once again. Both of them should be same. Otherwise, we can't apply. So here, whatever the first record is 1332 followed by 666. First record is 1332 followed by 666 followed by 1155 record followed by the same records. Whatever the extrain you are having here, the extrain whatever you are having here, both are same. Any difference is there? So up to extrain, there is no difference. Both of them are same to same. Now the difference starts from here. That is modeling. Here, what I have done initially, ridge regression with default parameters. Here, lasso regression with default parameters. For every algorithm, first you have to apply with the default parameters. What is meant by default parameters means you don't write anything inside the square brackets of the algorithm, then it is default. Default means automatically it will only consider everything. You don't need to write even one parameter also. So this particular algorithm consists of whatever the parameters are there. Every parameter is a default parameter. If you don't write also, that particular algorithm will work. Every machine learning algorithm is having the default parameters only. None of the algorithm is having with compulsory you have to write like this. There is no algorithm like that. Every algorithm is a, if you don't write anything also, automatically it will apply. Right? So it is having a default parameters. Now here from sklearn.linear model, you are importing the ridge, here you are importing the lasso, and you are going to store this particular ridge regression in some variable name. Here you are going to store the lasso in a variable name, and you are going to fit on xtrain. You are going to fit on the xtrain ytrain, and you are going to calculate the intercept value, quotient value, intercept value, quotient value. You are going to predict on the xtrain, xtest, predict on xtrain and xtest. You are predicting on xtrain, xtest. So if you want this one, I'll copy this one in a separately. Just give a minute. Okay, predict on xtrain, predict on xtest. Okay, the same to same. Here and here both are same. Next, you are going to do the evaluation, that is train R square, test R square and CV. Here also I'm going to do the same. Okay, first I'm going to calculate the train R square. I'm going to keep the same order. First, I'm going to calculate the train R square, followed by test R square, followed by the CV. And I'm going to execute. Whatever I have done here, I'm going to do here. Here I have got a different quotient values. Here I have got a different quotient values and different values. Why it is a different? Because this is ridge regression, this is lasso regression. It is going to apply based on that formula, whatever in the backend is there. Accordingly, how both will be the same? The formulas are different in the backend, right? This is alpha into slope square. The penalty term here it is alpha into slope square. Here the penalty term is alpha into modulus of slope. This is the penalty term. Since both of them are different, according to that, it is going to identify the equation and intercept value and values. What we have to do the hyperparameter tuning for each and every algorithm separately. Whatever you have done earlier, this hyperparameter is applicable only for ridge. This is not applicable for lasso, because these values will be substituted. Whatever the param grid is there, this param grid will be substituted in the ridge. Here estimator and param grid you are writing. So these param grid will be applied on this ridge. It is not going to apply on the lasso. So it is just applying only on the ridge. So similarly, I'm going to calculate based on the, guys, as one of the student is saying some audio problem. Is that clear now? Others? Okay, now it is clear, right? Okay, done. So here you are going to apply the same to same. Whatever you have done here, the same to same. Okay, the grid set CV estimator is equal to ridge. estimator is equal to lasso. For example, here alpha is equal to, you have to take the list of values. For the list of values, what we are going to do? These list of values, we are going to take the L. What is L means? These are the values. From where I have got these L values? By using the while loop. So I'm going to write the same while loop copy, and I'm going to use here also the same thing. I'm applying the while loop, and using the while loop, whatever the L values I have got, that L values I'm going to give here. L value. So now this one and this one are both are same. Is that clear? Just observe. Any difference have you find? Apart from the word called as lasso and reach, is there any difference? Right? So both I'm going to apply the same thing, and here I'm calculating what is the best parameter. So it is applying the best parameter, and it is saying the alpha is equal to 5.0 is the best one. Now, if you observe here, this is 0.9 is the best one, but 0.9 is the part of this one. So no need to try with the remaining values. But here, whatever the alpha is equal to 5 is there, alpha is equal to 5 is the not the best one, because 5 is the last. I'm trying up to 5 only. And that too, I have got the answer as 5. If I increase this one to 6, and I'm checking here, now again, I'm going to get the best value as 6. Means last value I'm getting as the best value. If the last value is the best value, what we have to do? Still, we have to increase the values. So I'm trying to increase the values. So what I'm going to do is, here I'm going to try up to 100. Okay. Now, it is going to apply multiple. So it will take so much of time. In your case, if your laptop supports for the hyperparameter tuning with multiple values, then only try. Okay. Otherwise, don't apply the hyperparameter tuning with more number of, see, here I can write even 10,000, 20,000, 1 lakh also I can write. But what happens means, next day I have to take my laptop to the service center. Immediately the moment my system will die. If I write 10 lakhs or 20 lakhs something, because it has to check for each of them and it has to identify the best parameter now. So now, for example, 100 are there. 100 means what is here? 100 meaning is 100 means inside that 0.01 you are adding, means from 0 to 1 only you are having 10 values. 100 into 10 means total 1000 values you are trying. One after one after one, 1000 models it is applying. Out of 1000 models, which is the best model it is identifying. 1000 models it is applying in the backend. If your system supports means okay. If your system doesn't support means it will die simply. You are going to get some kind of RAM issue or motherboard issue or something. Okay. Here the most important point which you have to write in the notes is SRK sir is not responsible for my laptop. That is the most important point, because earlier one student has tried with whatever the value he's interested, and next day the system was crashed and it is not even starting. He has came to me. I told her to go to service center only, and he has went and they told that motherboard has gone, pay for 25,000 it seems. His laptop is something, right? So in my case, I am working presently. Whatever my laptop is there, this is i7 with 16 GB RAM. This is the one which I'm working as of now. Okay, which I'm using for my training purpose. This is the laptop. For my office purpose, I'm having different. Okay, that is of 64 GB RAM. Okay, this is i7. i7 with 16 GB RAM. This is right. Now, since it is supporting, I'm trying that one. Here you should not, sir, if it is not supporting, then what we have to do, sir, means in your company, when you are working in real life in a company, automatically based on the project, according to the project, they are going to provide the laptop. Whatever the work you are going to do, based on that, they are going to provide the laptop. Sir, if the company doesn't provide the laptop, what we have to do? First you have to do is quit the company. That is the first step. Why, sir? Because they are not having the budget to provide the laptop, means how they can give a good increment in the future. In that company, there will be no growth. Though you work heavily also, they can't pay for you because they're only not having the budget for paying. In that case, we no need to prove our talent very highly. Instead of that, if you move to another company where for our talent, if they're paying something, automatically we'll also get the boosting something. And based on that, we'll work very high and we'll try to get into the next company or directly like that. And finally, we'll achieve our goals with respect to high package. If your requirement is package, no sir, not package is important, miss, then you can enjoy whatever you want as per your choice, right? Is that clear? Now coming to this here, if your data, whenever the last value is the best value, you have to try with the other values. Means you have to increase the value. Within the data only you have got the best value, means you don't need to try. In this case, first I have tried with 5. I have got the 5 as the best answer. Next I have tried with 6. 6 I have got the best answer. Next I have tried with 10. 10 I have got the best answer. Next I tried with 20. 20 I have got the best answer. 30. 30 best answer. 40. 50. Like this I'm going to increase. And I have tried up to 100, means 60 is the best answer. Still I have to try for 1000. In this only I have got the best answer. So what I'm going to do, once I identified the best parameter, apply the hyperparameter tuning I have applied for each algorithm separately. Same insurance data set. Earlier I have worked on the ridge. Now I'm working on the lasso. For ridge I have applied the hyperparameter separately. For lasso also I have applied the hyperparameter tuning separately and identified the best hyperparameters. What is the best hyperparameters? Means alpha is equal to 60 is the best hyperparameter. Now using this alpha is equal to 60, now I have applied. Now I got the train R square, test R square and CV. Now if you observe clearly, in this one of the quotient has become to 0. Directly 0. So this is beta 1 x1, beta 2 x2, beta 3 x3, beta 4 x4 and beta 5 x5. This is the beta values. Each one is beta values. Now for the second column, what is your second column? Whatever the second column you have given in your train data, that is gender. Gender is not important. For predicting the expenses, the gender is not important. Whether it is a female or whether it is a male also same. That is, it is saying that in that way. Now, so here, for example, I have created the model. Okay, the model. What is the model? From the lasso regression, what is the model I have got? From the lasso regression, what is the model? Miss beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus beta 4 x4 plus beta 5 x5 plus beta naught, where beta 1 is equal to 264.37, beta 2 is equal to 0, beta 3 is equal to 317.04, beta 4 is 373.19 and beta 5 is 23,621.9 and beta naught is minus 12,045.19. Now what is the first one? X1. What is the X1, miss? X1 is nothing but age. This is gender. This is BMI. This is smoker, not smoker, children. And this is smoker. Now from this particular lasso says that out of all of them, gender is not an important column, and whether the smoker is having the top priority because this beta value is very high. From this we can identify this particular feature plays a major role. If the person is a smoker, his expenses is going to be very high in the future. Okay, whether it is a whatever the hospital bill or whatever it is the insurance, or he has to take high level of insurance, means the premiums are going to be very high. Just if you open the policybazaar.com and he said that if you give about details of yours and you select any particular company, it will ask whether you are having a smoking habit or not, yes or no. Now you are going to click on the yes and check what is the premium value. you are going to get the premium value very high. And if you click on the no, you will get the premium value as less value. So for example, I'm having a smoking habit, but still I have given the answer as no. What happens? Your claim will not be settled. For whatever the purpose of taking the insurance will be there, right? For taking the insurance, if you lie also, they'll give the insurance. That is not a problem. When you ask the amount, that is the problem. There the problem will be there. When you claim that one, then the report will be there, right? In that report, the doctor will easily identify that you are already having the smoking habit, and he'll mention that one. Since you have given that one in wrongly while taking the insurance, your claim will be cancelled. That is one of the terms and conditions. In the terms and conditions, if anything was proved that you have given anything in the insurance while taking the insurance, you have given anything wrong, miss, we are going to cancel your insurance and no need to pay even 1 rupee also. That is one of the terms and conditions they'll keep in the bond, and we'll sign on it, obviously. So they'll take the advantage of that one, and they'll show that we are not going to accept your claim, and simply they'll reject that claim. So at the time of taking the insurance, we have to mention very clearly what is important. Now, from this particular data set, we can understand smoking habit will increase the expenses in the future. Of course, everyone knows. And same thing from here, we are able to identify. Okay. The same answer. Everyone knows that one. Outside, if smoking is there, means we'll have the lung cancer or something. Everyone knows that one. Even on the cigarette packet also, they'll write clearly. Everyone knows. But we will see some Mukesh ads also, right? He'll come at the starting and he'll say something, Mukesh ad. Okay. That also we know, but still we'll smoke. That is secondary. So from this data, we are analyzing. Finally, we are concluding which variable is important and which variables are not important. If they ask you, you have to say smoker is a most important variable. And which is unimportant variable, miss? Gender is an important variable. Who told you gender is an important variable? Lasso has told you that one. Miss model has told that one. So this is the part of the future selection technique. This is the part of the future selection technique where it is called as embedded method. In the future, we are going to discuss this one. Embedded method means after modeling, the models test that whether it is an important feature or not. Model tests that. We can't prove that one statistically, but model tests that whether it is an important parameter or a non-important parameter. So whichever the parameters are identified the model as unimportant, they are based on the embedded methods. These are called as embedded methods. Embedded methods means model tells that it is an unimportant feature. Is that clear? Right? So here we have got with respect to the gender column. Now what I'm going to do, my final model, already earlier, what is my X? What is my X variable means? Age, gender, BMI, children, and smoker. These are the 5 columns. Now out of this, again, I'm going to drop the one of the column of index number 1. What is there in the index number 1? Gender. Gender column I'm going to drop. Now what is my X? Total now, what is my X? Only 4. Now using the 4 and expenses, I'm going to rebuild the model once again with alpha is equal to 60. Now I'm having only 4 beta values. Now same. Now you might ask me the question, sir, earlier also train R square, test R square and CV same. Now also it is same. Then what is the difference? At least one variable you have reduced means time will be reduced, right? While doing this model, automatically one variable is not there means no need to analyze or no need to calculate the beta separately. Manual, nothing is required, right? So at least time will be reduced. The advantage is at least time will be reduced. Either sometimes accuracy will increases. If the accuracy is not increased also, at least time will be reduced. That is the advantage of hyperparameter tuning. Now for this entire data set, what are the things we have done the data pre-processing? First, what is the data EDA is common. EDA is for checking. Okay. After EDA, what is the data pre-processing we have done? First, region we have dropped. This is the first one. Drop the region. After dropping the region, what we have done? Drop the duplicates. After dropping the duplicates, next what we have done? Encoded the gender column. We have done the encoding of gender. And next, encoding of the smoker. After that, next, X and Y we have considered, done. Model was done. Everything was done. But for creating the final model, once again, we have dropped one more column. What column we have dropped? Gender column also we have dropped. So in order to get this final model consists of only 4 input columns. What are the 4? Age, BMI, children, and smoker. These are the only 4 columns it is having. Now, you are having a prediction on a new data. Now tell me, your model was designed on how many beta values? How many quotients? 4 quotients. How many intercept? 1 intercept. So now how many variables your model was designed? On 4 variables or 4 features it was designed. Now I'm predicting on a unknown data. This is unknown data. For unknown data, I'm asking what is the answer? What is the unknown data, miss? Unknown data, age of 31, gender of female, BMI, children, smoker, and region I'm having. For unknown data, now unknown data consists of how many columns? 6 columns. Out of 6 columns, again, if you observe this 6 columns, okay, that 6 columns, out of which 3 of them are categorical. And if you directly give to your machine and if you ask to predict how it will multiply, here you have to take the beta naught, beta, whatever the beta into age, okay. Age value 31 is there, 31 into 264 it will do. Now 317 into what? BMI. BMI is 25.74, okay. 373 into what? Children. Children is 0. Okay, that is also okay. Next, 23,621 into smoker. Here smoker is no is there. How it will multiply that one? How a int can be multiplied to a string? So this has to be encoded. Otherwise, it will throw the error. If you ask directly, if you predict on the model, whatever the model, what is the final model name you have saved? This is the model name. Lasso best. This is the model name. Using your model directly, if you ask to predict on whatever the test data is there, df underscore tester, it is going to throw the error. Why? Because this particular model was designed with 4 values, but you have given total 6 values. Right? So that is the reason it is throwing. Then what we have to do? First, we have to drop the region column. First step, we have to drop the region column. After dropping the region column, what is the second step we have to do? First step is drop the region column. Next, duplicates. Here only one record is there, no duplicate. No need of writing the duplicates. If you write also, no problem. df underscore test dot drop duplicates. If duplicates are there, it will drop. If no duplicates are there, it will not drop. So drop duplicates. After that, encode the gender column. You are going to encode the gender column. After that, encode the smoker column. You have encoded the smoker column. After that, what you have to do? You have to drop the even the last one, which is called as gender column. Gender column also you have to drop. So I'm dropping even the gender column. Sir, why you are writing like this, sir? You can write here itself the gender also, na? Directly here itself you write the gender. Here itself you can write the gender. Not a problem. Okay, if you want to, you can write here itself, but you have to take as a list. Directly you can drop here itself. You don't need to drop separately here. Is that clear? So you're going to drop the region, gender column and drop duplicates, and along with the, you are going to do encoding of the already gender is gender means nothing but sex, right? So sex column you can drop. So for encoding of sex also you no need to do, because you are dropping anyways. So you are dropping the region column and you are going to drop the gender column, that is sex column, and Directly you are going to do the encoding of smoker. That's it. This is sufficient. So whatever is there, just I'm going to do this one. And after this, just I'm going to check what is my latest df underscore test data. Let me check. So total 4 values are there. That too 4 of them numerical are there. Now this same 4 data, I'm asking my predict on the df underscore test. df underscore test. Earlier it has given the error. Now this time it is working. Because earlier you are having the 6 columns, now you are having only 4. Earlier you are having with respect to encoding problem, here there is no encoding problem. Just it is going to apply these 4 values in the equation, whatever the equation it has created, and it is predicting the answer. Is that clear? Step by step. Now what is the difference in the last class of Ridge and today's class of Lasso? Miss, only additional difference is here, up to here we have done in the Lasso. I mean, in the Ridge also, we have done the default model. After that, we have applied the hyperparameter tuning. And after that, we have rebuilt the model. Up to here, we have done. In the Ridge and here, if you observe, up to here, it is common. Now, additionally, here we identified one of the future is unimportant. Directly, it has given the answer as 0. This is the additional one. For Ridge, it is not going to give like that. Sir, in this data set, it has given the answer as 0. For other data set also, it will give a. It may not. But if it has given for whichever the future it is giving the answer as 0. For whatever the future, the beta value is equal to 0. That future we have to drop. Sir, if I don't drop, what happens? Simple. It is going to multiply 0 into. If it is multiplying 0 into also, answer is going to be the same. Answer is not going to change. But calculation time will be reduced at least. If you drop miss, the final model calculation time will be reduced to some extent. Okay. In this way, we are going to predict the expenses of a unknown data. If you want to predict on a future data, then what we have to do? If you want to predict on a future data, what we have to do? First, we have to do the data pre-processing. Only the pre-processed data we have to use for prediction purpose. This is the most important point. After pre-processing only, you have to predict on the future data. Without doing the data pre-processing, directly we can't apply the predict on the future data. That is the most important point which you have to write in the notes. Okay. If you want to predict, in the notes you have to write, if you want to predict on unknown data, if you want to predict on unknown data, first unknown data has to be pre-processed. First unknown data has to be pre-processed, then we have to predict. And then we have to predict. First, it has to be done data pre-processing. And that too, the data pre-processing, whatever the pre-processing, it has to be pre-processed, is there, right? This pre-process as per whatever we have created the model. In order to get the best model, in what way we have done the pre-processing, the same thing. For example, in the data pre-processing, you have got the best model. This is the best model. How you got this best model, miss? Based on this data. From where you got this data, miss? You have done the data pre-processing. For example, here, there is some missing values. And missing values you have dropped. Assume. You have dropped the missing values, miss. Here also the missing values has to be dropped. On unknown data also, the missing values has to be dropped. For example, there, you have dropped, for example, you have filled the missing values. Age is a missing value is there. Assume that in the given data set, one of the age is missing. This is missing. This is missing. Remaining all of them are present. Only one value is missing. And you are filling this missing value with the mean. You have calculated the DF of age. First, you have calculated the DF of age column dot mean you have applied. and the mean you have got as 24.6 something. This is the mean value. You have got some mean value like this. Now, whatever the mean value you have got in the unknown data, if in unknown data, let us take like this. For unknown data, you are having a missing value. Here, the age is not there. For unknown data, age is not there. Then, how you can calculate the mean for this? For unknown data, can you calculate the mean? No, right? Directly that previously, whatever the mean you have calculated, that you have to fill here. Directly you have to fill. You should not fit and transform. Directly only transform you have to do on the unknown data, only transform, not fit. Fit is applied only on the before data. Is that clear, guys? Next, coming to the elastic net. Finally, the elastic net. Let us observe this elastic net. Same data set. I'm not changing the data set. I'm taking the same to same data set. Everything same, dropping everything. And the train data also same to same. Whatever I have applied here in the lasso regression, same to same data. Both are same. Is that okay? Up to train test split, I'm not going to change. Only the modeling. Sir, if up to train test split is everything is same, then why you are writing in another Jupyter notebook? It is mandatory to take a new Jupyter notebook and there you have to apply all these things. It is not like that. You can do on the same Jupyter notebook here itself. You can continue and you can keep a heading called as elastic net regression and you can continue. But instead of continuing in the same, I'm trainer and you are the students, you are listening for the first time and I have to explain for you easy way, right? That is the reason I'm taking in a new Jupyter notebook. In real life, I no need to go with a new Jupyter notebook. I can continue in the same thing, right? So here the modeling from sklearn.linear model, import the elastic net. And I'm going to fit on the X train, Y train. I mean, fit on X train, Y train. And then I'm going to do the prediction on X train, prediction on X test. And I'm going to calculate the train accuracy, test accuracy, and CV. And this time I have got the train accuracy of 40%, test of 36% only. Means elastic net regression default is not applicable for this particular data set. It is giving very worst answer. Now I'm going to apply the grid search CV. Now in the grid search CV, this time I'm going to take a different alpha values and different L1 ratios. Now what it is going to do? It is going to apply the with respect to a combination of both of them. So for one alpha, if you observe here in the default parameters, what is the alpha value it is considering? 1 and L1 ratio of 0.5. What is meant by 0.5 means 50% alpha, 50% lasso, 50% reach. That is the meaning. Now what I'm going to do is, I'm going to try first with alpha is equal to 0.1. First I'm fixing alpha is equal to 0.1. Alpha is equal to 0.1 and L1 ratio is equal to 0.1 and L1 ratio of 0.5. Second, alpha is fixed. Alpha is not going to change. 2. Next, I'll try with 0.75. 3. Next, I will try with 0.9. Next, I will try with 0.95. Next, I will try with 1. Okay. First, with alpha is equal to 0.1, I will try total 6 models. 1, 2, 3, 4, 5, 6. First, this is the first model, second model, third model, fourth model, fifth model, sixth model. In each model, the alpha is 0.1 is fixed every time. Now, alpha with 0.1, 6 models I have completed. Now, what I'm going to do with next, with 0.2, again, I'm trying 6 models. With alpha is equal to 1, I'll try 6 models. With alpha is equal to 2, I'll try 6 models. With alpha is equal to 3, I will try the 6 models. Like this, we are trying with the different alpha values with different L1 ratios, a combination of both of them. In the backend, what happens means just it is applying the nested for loop. Nested for loop. Now, if I write like this, just tell me guys, for I in range, not range, for I in, just tell me Just ignore the elastic net regression and everything. For I in list of 1, 2, 3, for j in 4, 5, print I, j. If this is the program, what is the answer? There is no elastic net, there is no nothing, just a normal core Python basic code. What is the answer of this particular program? First 1, I is equal to 1 with j is equal to 4, it is going to print 1 and 4. From here, where it is going, here or here? Again, only here. And now 1, 5. With 1, everything is completed. Now it is going to try with 2. 2, 4, 2, 5. Next, 3, 4, 3, 5. This is the answer, right? Same thing. Here, instead of this one, I am writing for alpha in list of 0.1, 0.2, 0.3. For L1 in 0.5, 0.6, 0.7. Now, what would be the answer? First, with alpha of 0.1, L1 of 0.5, L1 of 0.6, L1 of 0.7. Now, alpha is equal to 0.2, L1 of 0.5, L1 of 0.6, L1 of 0.7, followed by alpha is equal to 0.3, L1 of 0.5, L1 of 0.6, L1 of 0.7. Same thing, right? The same thing will be applied in the backend. For each alpha value, it is going to try with the different L1 ratios. Just it is going to apply the nested for loop. First, it will fix the alpha is equal to 0.1 and it will try all these things. 0.2, all these things. 1, all these things. 2, all these things. Just in the backend, nested for loop will be applied. Now, once it is applied all these things and I'm identifying which is the best parameter, and I have got the best parameter as alpha is equal to 40 with L1 ratio is equal to 1. Whatever the best parameters I have got, I'm using the same best parameters here. That is alpha is equal to 40 and L1 ratio is equal to 1. Now, what is meant by L1 ratio is equal to 1 means it is nothing but alpha, lasso regression. 100% of lasso you are considering. 0% of ridge you are considering. What is L1 ratio? L1 ratio means how much percent of L1 you have to consider. L1 ratio means percentage of L1 to consider. You have got here 1. 1 means equal to 100%. 100% of L1 you have to consider. What is meant by L1? Lasso. 100% of lasso you are going to consider. Right? So whatever the parameters you have got here, using that parameters, you are going to create the model. Now, if you have applied the lasso, automatically the value is going to be 0. The beta quotient is going to be 0. Again, is the same way. For example, instead of L1 ratio of 1, you have got L1 ratio of 0.9. Something like this you have got. Then you are going to apply whatever the values you have got and according to that. Now, in this case, the second column will not be deleted. Since the beta value is not equal to 0, we should not delete that one. If the beta value is equal to 0 only, we have to delete. Is that clear, guys? Yes. Now here, if you observe this one, whatever the data set is there, the data pre-processing, and here, just you check with respect to whatever the data points we have dropped. And here the lasso, whatever the lasso regression, 1069,5, and here also it is 1069,5, and lasso. You can see here what is the train R square and test R square. If I am taking the lasso is equal to 1 with alpha is equal to 40, 75.92. Here the difference why it is showing very good point. Basically, here the scoring, whatever the scoring I have taken is R square. I have considering based on the R square. In this case, what is the scoring I have given is mean square error, RMSE. So just I'm changing this one to R square. Now let me re-execute once again and run all the. So now I have got 55. Can you tell me why I have got 55 here? Because in the given alpha, there is no even 60 also. From where it will check 60. So if I add 60, if I add even the 60 here, then automatically now it will try with that. Now we will get automatically 60 as the best. Is that clear now? Done. Now you can write the scoring is equal to either R square, means if your project you are working based on the R square, means you can write the scoring as R square. If your project is RMSE, you have to focus on the RMSE, means you have to take the scoring is equal to mean squared error. You have to write the mean squared error. So the mean square error you want higher, lower. Whatever you are writing here, it will by default it will take the high, means it is identifying the best parameter which gives the highest mean square error. But I don't want highest mean square. I want the least mean square. Least mean square error means negative. NEG we have to add. NEG says that you are having the opposite, means you are focusing on the which is parameters gives the least RMSE value. That is the meaning of that. Which gives the least RMSE. If you want the least RMSE, which contributes the least RMSE, means you have to write here negative mean square error. Negative mean squared error. Then it will identify now the best parameters. Now same number of models will be applied. Earlier it has calculated the R square for each model and it identified the which gives the highest R square. This time it will identify, every time it will calculate the MSE value and it will identify which gives the least MSE value. Least MSE means automatically least RMSE, right? MSE is low means RMSE is automatically low, right? So if your project is based on RMSE means, then you select the scoring is equal to mean square error. If your project is based on the R square means, select this one accordingly. Is that clear? So just you can try this one. And today you complete this, whatever the task and whatever the things we have done, that is lasso and also with respect to elastic net regression. Try to complete this one. And in the tomorrow's class, we are going to start the classification. In tomorrow's class, we are going to start the classification. And I'm going to upload one data set, a new data set completely. And that data set I'm going to upload tomorrow morning. Tomorrow morning at 10 o'clock, I'm going to upload a new data set. For this new data set, you are going to do the entire EDA, followed by data cleaning, followed by data wrangling, apply the linear regression, apply the polynomial regression, apply the ridge regression, lasso regression, elastic net regression. Everything you are going to apply and tell me which is the finally the best algorithm for the given data set. This is your assignment. Tomorrow morning at 10 o'clock, I am going to upload the data set and you have to work on that assignment. In meanwhile, complete the today's class. Today, after the class, just try to complete whatever the elastic net regression and lasso we have discussed in today's class. Try to complete that one. And just let me check whether I have uploaded the notes or not. So already I have uploaded the lasso, ridge and elastic net regression. Dataset was not uploaded. Just to give me a minute. This upload problem you are not going to face for the classification, because next time I'm going to upload the entire classification folder at a time. Otherwise, I'll forget. Again, you'll face some issues. Instead of that, I'll upload everything. Okay. Tomorrow, I will upload everything of classification. Means next 10 days also, I will upload before itself, so that you will not face any kind of problem. Is that clear, guys? And also weekly test. Just give me a minute. Mock test. So last mock test, in this class, how many of you have attended the mock test on Saturday? Done. And is the mock test is easy? Okay, let's try. So when they have given the paper, 4:30 to 6 hours. In 1.5 hours, it is difficult to complete. Okay. For 6 p.m. batch, this is the mock test question paper. Yes. I have uploaded the mock test also. Please, whoever has not attempted on Saturday after the class, today you try to complete this mock test if possible. Is that clear, guys? So most of the questions, whatever the most of the questions in the future, if you type in the Google interview questions on data science, most of the questions will be the same. 90% of the questions will be the same. Right? Done. Last or which we have to apply. Sometimes it might be suited, sometimes it might be not suited. Whatever you are saying, it is not applicable every time. Tomorrow I'm going to share you the data set now. Today you try this one. Whatever the logic you have asked, just apply the same logic on the advertising data set is already with you. And expenses data set also already with you. Just to apply the logic. And tomorrow morning I'm going to upload the assignment now. Just check. If for every data set it is applying means that logic is correct. Only for one data set it is applying means we can't confirm on based on one data set, right? Yesterday, one of the student has asked us, sir, still that test CV and train aspire and test aspire, not much change is there. For that data set, it is not giving the much change, but tomorrow's data set or for advertising data set. So he is going to try for now after the class for advertising data set, he is going to apply and he'll check whether hyperparameter tuning is going to change the test aspire or something. If there also it is not changing or still it is having some kind of overfitting still there also, then based on that, then we can conclude. But based on single data set, conclusions we should not give. Is that clear, guys? Done. Elastic net is mandatory. Yes, every date. See, mandatory means maybe who knows in elastic net regression you may get a best answer. Who knows? Right? And I'm facing one problem in train test split, and test is taking 80% data for testing and 20% for training. Kamal, between 4 to 6, I have already shared you the Zoom link, right? Between 4 to 6, you can use that one and you can join and you can share your screen. So we can identify what is the mistake. You can join between 4 to 6, right? Already we have shared you the Zoom link also to ask whatever the doubts you are having and whatever the things. Right? Done.